All right, guys, happy Monday and happy February 1st. So, this video is to go over what we did in class today. So, before I get going with the math, there's some announcements that I just want you to focus in on. This week, all of our math classes will be starting at the same time. So, Wednesday, where we normally have a different schedule, Wednesday will be the same as Monday, Tuesday, Thursday, and Friday this week. So, again, your math class will start at the same time. Please check with your special area teachers about what your afternoon will look like. Also, a reminder to families that the resource pickup bags will be available Thursday and Friday of this week. So please make time to come on over to Ritter School between 7 and 12 to pick up your bags. Also, 15-minute iReady requirement every week. So again, try and get that done before class on Friday so you can participate in a reward for those students who have completed their responsibilities. I also want to let you know that last Friday we took a Jamboard adding check-in, and your assignments were graded and returned to you so you can see the grade that you got, any comments that I left, as well as I posted the answer key for you to review your work with the correct work. You can join me during office hours if there's anything that you want me to go over. All right, so to start this activity today, we are taking a look at a new kind of model, and you're going to see that pop up in just a second. All right. So here you can see that this model looks somewhat similar and somewhat different to what we did last week. And you are being asked to, on this slide, think about what do you notice? What do you wonder? And what about this model? I know it says his, but what about this model is the same and or different from last week's model? So again, keeping those questions in mind, thinking about what do you notice? What do you wonder? And what do you notice that is the same or different compared to what we were doing last week? Now's a great time to push pause on the video and go ahead and think about those questions. All right. So, taking a look at this model, some of the things that maybe you should have noticed, let me get my text box, is maybe you notice that there is shading. Maybe you notice that there are X's on the model. Hopefully you also notice that it is a hundreds grid, or we can talk about it how in decimals, a grid equals one whole. All right. So coming over here to what is the same and what is different. So let me bring my box right over here. And again, some of the what you notice will be also over in this third category. Maybe again, you notice that there is shading, but this time there is only one color. One color shaded. Okay. Something that's also the same. We talked about a hundreds grid, different. We talked about how there are X's overlapping the shading. So what do you wonder? Maybe you're wondering, well, is this the same type of problems that we did last week? Is this a new type of problem? Maybe you're wondering, is it a different operation? And if you were wondering if it's a different operation, you are correct. So this model that we just looked at represents subtraction. So again, we're going to be now moving towards subtracting decimal numbers using models and the standard algorithm and building that connection between the two of them. So taking a look here, you can see across the bottom, we have some clues about we have some clues about what each number in our subtraction problem represents. So the first number is what we're starting with, the total. So in this case, we're going to look at everything that is shaded. So taking a look, everything that is shaded in pink is what we started with. So because we know that an entire grid, and I'll just remind you, an entire grid equals one whole. And here you can see, well, everything is going to be less than a whole because I'm working with an entire grid that's not even shaded. So everything, again, we're decimal numbers, and everything is less than one whole. So the first number is the total amount that's shaded. So we see that we have one whole column, which is 10, 20, 30, 40, 41, 42, 43, 44, 45. There are 45 little boxes shaded in. And we know that 45 little boxes are hundredths. So we're starting in this problem with representing 45 hundredths. The next part is we have to figure out what we crossed out. The part that's crossed out represents what we're subtracting. So we started with 45 hundredths, and now we're going to look at, well, what did we take away? And we're taking away everything that is crossed out. So you can see that we took away one whole column, and we know that that's worth 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 little boxes represents 18 hundredths. Finally, the answer to our subtraction problem is called the difference. And the difference or answer is going to be everything that's shaded that is not crossed out. Okay, so everything that is shaded that is not crossed out. So this part here tells us what remains. So taking a look, you can see we have two whole columns. Each column is worth a tenth. And then we have 1, 2, 3, 4, 5, 6, 7 more. So a total of 27 little boxes or 27 hundredths. So again, this new type of model represents the subtraction problem that you see below. Let's take a look at another one. All right. So once again, our first number, we're going to take a look at everything that's shaded in because that tells us what we're starting with. So everything that has blue in it represents what we're starting with. All right, so I have 1, 2, 3, 4, 5, 6 total columns filled in, and that little extra makes 61 little boxes. So I have 0 whole grid shaded in, and I have 61 little boxes for 61 hundredths. So that gives us our first number. So now let's look at what our second number in our problem represents. Now it says that we have to take away, and taking away means I crossed out some stuff. So I'm going to be looking at all of this. That represents what part of the shade is being taken away. Again, I have that one entire column, 11, 12, 13, 14. So again, I have 0 whole grids and then 14 little boxes for 14 hundredths. So far we have 61 hundredths minus 14 hundredths. And let's take a look at what our difference will be. Again, the difference is the answer. And that is represented in the blue part that is not overlapped with an X. So again, you can see 1, 2, 3, 4 total columns. So that's 40, 41, 42, 43, 44, 45, 46, 47 total little boxes for a difference of 47 hundredths. And the best part is you can check this using the standard algorithm, which we're going to get a lot more practice with later on in the week. But if I line it up using my decimal points and my place values as a guide, 1 minus 4, can't do that. So I'm going to regroup. 11 minus 4 is 7. 5 minus 1 is 4. Bring down your decimal point, and here's your 0. You can also use the inverse operation or fact families to check by doing addition. So here you can see instead, maybe I want to take my 47 hundredths plus the 14 hundredths, and it should give me the total amount shaded. 7 and 4 is 1, or is 11, excuse me, carry the 1. There you go. So again, you can see how we checked using addition. All right. So on this next slide here, we had the opportunity to model our own. So the first thing that we need to do is shade in the first amount. So I'm going to hit the highlighter. I'm going to adjust the size of the pen, and then I'm going to select my shading color. So the first thing I have to shade in is 4500s, and I'm using these little clues down below today to help me with modeling. So 4500, so that means I'm going to have one entire column, 2, 3, 4, and then 5 more. 1, 2, 3, 4, 5. So now I need to go ahead and cross out. So I'm going to switch over, and I know I need to cross out 1500s, and 1500s means 15 little boxes. So what I'm going to do is I'm going to start at the end and work backwards. And you saw that in the model. They all started crossing out from the right side going this way. So instead of using X's, I'm just going to use little slashes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you can see that first I colored in with my yellow shading highlighter. I crossed out 15 hundredths using the black marker, and the only thing I have left to do is go ahead and find my total answer. My sum, excuse me, not my sum, my difference. We're doing subtraction here. So taking a look, it's everything that's not overlapped. And you can see that that's 0 holes. And maybe you were thinking there's 30 little boxes, and you can write it as 30 hundredths. Or if you notice that it's 3 rows or columns, an equivalent decimal to that would be 3 tenths. All right, we got one more to take a look at. So taking a look at this slide here, once again, we modeled the subtraction problem. So I'm going to select the highlighter, go ahead and pick my color, and I have to start by modeling 8300. So that's the first thing. Shade in what we're starting with. Think about maybe I'm starting with 83 cents. Think money. All right, so I'm going to go ahead, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, and then 3 hundredths more. All right. So again, you can kind of see that shaded in. I'll add some extra shade throughout, get rid of all of those white parts. And again, it's super important that you're being as neat as possible when you're shading. All right. So again, you can see to the best of my ability, I have shaded in 83 hundredths. So now I need to go ahead and cross out 2 tenths. This is very important. 2 tenths. 2 tenths is equal to 20 hundredths. So I need to cross out 20 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you can see I started with 83 hundredths. I went ahead and I crossed out 2 tenths, which is equivalent to 20 hundredths. And then the part that is remaining, all of this represents the difference, which is the answer to my subtraction problem. So all I need to do is go ahead and count the part that's green that does not have anything crossed out. So let's count by tenths. 1, 2, 3, 4, 5, 6 tenths. So again, I have 0 holes. I have 6 tenths, and then I have 1, 2, 3 hundredths. We can check this just like I showed you before. All right, so let me clear some space over here. So when we check this, it's really important that we line up our place values. And in this case, I have 0 and 83 hundredths, and I have 2 tenths, so I have a 0 decimal point 2. Just like with adding, and more importantly with subtraction, you have to put that 0 as a placeholder. Then I go ahead and subtract, bring down my decimal, and you can see that my differences are the same in both my model as well as when I use the standard algorithm. Tomorrow we will be continuing to practice modeling with subtraction. If you have any more questions, please join me at office hours.